So let's start doing some of the exercises now where we actually apply this idea of composition of functions. We're going to do exercise 1 here, and I've copied the, I copied the problem onto a separate sheet. So I started renumbering with this handout with this idea of composition of functions. It's its own topic here. So we're given the function f of x equals x squared plus 5, g of x equals x plus 1 over x minus 1, and we want to find and simplify each of the following. First, f of g of 2. So think inside to outside. First, I want to find this quantity on the inside, g of 2, and I'm going to plug that in to the function f, is what the idea is here. So I would say aside, I'm just going to say, well, what is g of 2? Just going to figure that out. And here's the function g of x. So g of 2 is 2 plus 1 over 2 minus 1, or 3 over 1, or 3. So g of 2 is equal to 3. I just plug that in here. So the output of g becomes the input of f. So at this stage, I can work right here in line. I'm going to plug 3 into the f function. Now it's true, this 3 is like a y value for g. It becomes an x value for f. 3 squared plus 5, right? I'm using the formula for f. That's 9 plus 5, or 14. So f of g of 2 is 14. Now we're using the same functions, and we're going to do g of f of 2. Now it's got that little circle symbol, but what I would do is just leave these functions in the same order and just write this with layered parentheses. So it's like f of 2 is the innermost layer. The next layer is the g of. So in this part of the problem, we have to figure out f of 2 first. And so I would say aside, I'm going to figure that out. F of 2, what is that? Well, I have to go back to my expression for the f function, x squared plus 5, and plug in 2 squared plus 5. 4 plus 5 is 9, right? F of 2 is 9. So back here in what we're calculating, I'm going to take g of 9, what I just got for f of 2. Now what came out of the f function goes into the g function. So I plug that 9 into the g function using the formula up above. So it's kind of like I forget where it comes from, right? Maybe it came out from being a y coordinate, but now I forget about that. It's just a number. It's an input for g, so it's like an x value for g. 9 plus 1 over 9 minus 1 when I plug into the g function. And I get 10 eighths, which is 5 fourths, which is fine. Okay, 5 fourths. I'm sorry, I went below. There we go. So there's part A and part B for exercise 1. Now I'm going to jump to another sheet, and I'm going to try to keep the F and G, because we need to keep referring back to those functions. And now what we want to do is calculate this. F composed with G of x, part C. So with an x here, not with a number. We're working just with the variables. And I'm going to rewrite as f of g of x with layered parentheses there. And again, I'm going to do what's inside first. Now, I can't evaluate g of x. I can't calculate it. All I can do is plug in its expression, which is x plus 1 over x minus 1. I'm going to write inside the f parentheses. Now, to take this further, I'm going to take my definition of f as x squared plus 5, and I just want to remind you guys of that version where I said f of a box is box squared plus 5. So whatever is in parentheses here goes in the parentheses here. If it's a big mess of stuff like x plus 1 over x minus 1, I didn't draw my box large enough, it's got to go over here. So that's how I evaluate this portion of the composition now. I'm going to plug that entire fraction into the f function. And so I have to take x plus 1 over x minus 1 squared and add 5 to it. Okay? And for me, it's okay to stop here. If you want to simplify it further, if any of you are just dying to know what happens if we combine these into a single fraction, send me an email, let me know, and I'll write it up. I'll send it out to you, or we can compare notes. But I wouldn't ask you to go further with that. Okay? And there's that composition. It's kind of like you still see the g function in there. You see the effect of the f function, the squaring, and the 5. And try to, this is a good one just to look at and see. G is like the inside function of this process. F is like the outside function. Okay, let's do another. Let's do D, where we compute G of f of x. So this is different now where I change the order because I'm going to plug f into the composition of G of. There's no way I can simplify that f of x. I just have to take the expression x squared plus 5 and write it here. But now I got to figure out what the heck does this mean, g of x squared plus 5. Well, g of box, I'll write a bigger box this time, is box plus 1 over box minus 1. I'm replacing x with a box, because the idea of the g function is whatever is in parentheses here goes in each of these positions where an x was before. So if I have x squared plus 5 in here, I have to write an x squared plus 5 here and an x squared plus 5 here in both those positions. So that's what this composition is going to look like. I'm going to have this fraction with x squared plus 5 in parentheses plus 1, x squared plus 5 in parentheses minus 1. And this one I am going to clean up a little bit because it's real easy to simplify this. The parentheses don't mean multiply. There's no multiplication. I'm just adding. The parentheses are just grouping. But that's the same as x squared plus 5 plus 1 with no parentheses, x squared plus 5 minus 1 with no parentheses. So when I combine like terms, I get x squared plus, that's going to be 6 over x squared plus 5 minus 1 is 4. And there's my composition. Now, I think that this is also an example where when you simplify a little bit, you kind of lose sight of where the original functions are, right? Okay. Let's go on to E. Let's do f of x. Composition of a function with itself. I'm going to replace what's inside parentheses with f of x, x squared plus 5. And then I have to apply f again. For the second stage is where I got to think of that box business. So I'm thinking of f in a more abstract way. If I put x squared plus 5 here, x squared plus 5 here, what I end up with is x squared plus 5 in parentheses squared plus 5. And really, I'm pretty happy with this. I'm going to go ahead and multiply this out just so we get a little algebra practice. But see the layering of the, there's a 5 here and a 5 here. There's a square there and a square there. So you can kind of see this iterative effect of f applied over and over again. Now, if I multiply this out, what do I get? I get x squared plus 5 times x squared plus 5 with a 5 added on. So that's x to the 4th plus 5x squared plus 5x squared plus 25 plus 5. 5 times 5 is 25. So this would look like x to the 4th plus 10x squared plus 30. Looks totally different when I multiply it out. I kind of like it better at that earlier stage. And I think we got time to do, yeah, we're going to do f, because it's also part of this problem. G composed with g, G-O-G, rewrite as g parentheses x, g of x. I know I'm going to replace the g of x inside with x plus 1 over x minus 1. Ew, this is going to be a mess. This is going to be a mess because g of whatever is whatever plus 1 over whatever minus 1. And what's going to happen here is I have to put that x plus 1, x minus 1 here, here, here. And so what I end up with for g of x is a huge complex fraction. I get x plus 1 over x minus 1 plus 1 over x plus 1, x minus 1, minus 1. And that, you see the structure there of what happened with the composition. Now, let's go ahead I'm going to go ahead and simplify this. This is good algebra practice. I like to always think of these complex fractions as division problems. So I'm going to take x plus 1 over x minus 1 plus 1 and divide by x plus 1 over x minus 1 minus 1. Now, I can't leave it written this way because it's understood when you have a complex fraction that everything in the numerator is grouped and everything in the denominator is grouped together. I need those parentheses. And I first need to combine in the first parentheses and the second parentheses before I can do the division. The division has to wait. So luckily I have just plus 1. It's not too hard to write a 1 as a fraction. I have to use the common denominator of x minus 1. And a 1 is always going to be something over itself. So it's got to be x minus 1 over x minus 1 divided by x plus 1, x minus 1. Minus 1 in this case. Again, same denominator. So I write x minus 1 over x minus 1. Now I combine x plus 1 plus x minus 1 over x minus 1. At that point, I don't need the parentheses anymore because I have just a single fraction. And the second, tricky part, do you see? What I wrote is wrong right now because I need grouping here. This minus sign needs to be distributed through the terms that follow. So that's a crucial step to recognize that parentheses, and which I almost forgot to show on the screen. So I have 2x, 1 minus 1 is 0, over x minus 1, divided by, this is going to become, just to save a little space, x plus 1 minus x plus 1, right, when I distribute that minus sign. So I'm going to have x minus x is gone, but 1 plus 1 is 2 over x minus 1. So I have 2x over x minus 1. Finally, I can convert to multiplication. Invert the second and multiply. The x minus 1 will cancel. A 2 factor will cancel. I'm left with x over 1, which is just x. That's the simplified form of g composed with g. And that's the end of part F.